Hey guys, I'm Deco. Thanks for clicking on this video. Today we're going to talk about undefined behavior in C++. Specifically, we're going to talk about uninitialized variables and how it causes undefined behavior. Uninitialization of variables is one of the most common causes of undefined behavior, and it also is some of the hardest code to debug when undefined behavior occurs. We will be following the learncpp.com lesson 1.6. So if you haven't already read that, go over there, turn off your ad blocker, show them some love, and then when you're finished reading, return here. So let's get started. All right, so again, we're working on lesson 1.6, uninitialized variables and undefined behavior. We start off with a little bit of review from prior lessons. Now, in languages such as C and C++, it's important to note that variables are not automatically initialized. So what this means is that we have to specify with these brackets. So in this case, we're zero initializing. So this pH value will be 0 whenever we use it next in our program. So before we assign it here, this pH value is actually 0. And then it's changed when we calculate the pH via this function. This is technically default initialization when we don't have the brackets. We talked about all this last time, but this is just a quick review. Technically, although it's called default initialization, we're not actually initializing this variable with a value. Essentially, what we're doing is we're giving it a memory address to store data. So we're initializing it in that respect. However, the data at this memory address is garbage. It's whatever value was there before our program even began. So it's very unreliable, essentially, to default initialize your variable unless you know for sure that you're going to assign it later on in your program, like 100% sure. But even then, when you're learning, it's better to always initialize your variables when you instantiate them. So a variable that has not been given a known value through initialization or assignment is called an uninitialized variable. So right here, we're using default initialization, and later we're assigning it. So this isn't a uninitialized variable anymore since we've assigned it a value. So just keep that in mind. You can initialize or use assignment. And it's also important to note that initialization and uninitialization in C++ are not strictly opposites, okay? And so what do we mean by this? Well, in common language, initialization of an object just means that we provide it an initial value at the point of definition. Uninitialized means the object has not been given a known value yet, okay? So an object that is not initialized but is then later assigned is uninitialized. So that's what we just talked about, right? So assignment can turn an uninitialized value into an initialized value. All right, let's see what do we have here. In lesson 1.4, we noted that when no initializer is provided, this is default initialization. So it doesn't really make sense, but hey, whatever. Okay, so as a aside here, there is a reason. You might think, oh, well, why is this default initialization even present in C++ and C? Like, why does that even make sense? Why give a variable a random memory address that doesn't have a data value in it? Well, the reason is from the early days, if you had like 1,000 values from a file to read, and you had to create 100,000 variables, imagine like setting this to some dummy value. So let's say, just say 0, but having to initialize 100,000 of these with some value that we're later just going to change in our program. That doesn't really make too much sense. So that's kind of the genesis of this whole process and why it is the way it is today. For now, as a beginner, you should always initialize your variables because the cost of doing it compared to the benefit just isn't worth it. It's not there. And using values of uninitialized variables can lead to unexpected results. This can print out, right here where we're default initializing, this can print out 7, -7, any value, you really don't know, because it could have been a different data type before. It could have been used by some other application or something, and might just give you some random minutia. And it's important to note that some compilers differ and will initialize the memory to some preset value before you can actually see like that undefined behavior. And this is usually present in like debug builds and Visual Studio. Yep, so you might get some errors when you try to run this, because it tries to find out when a variable is uninitialized, and can cause, later we'll find out in just a sec, undefined behavior. And here's just another way to get past this if you end up getting this error and want to see the potential undefined behavior. Undefined behavior. So undefined behavior can be caused by several things, not just the uninitialized variable, but we'll cover all those in future lessons, so don't worry about that. So undefined behavior essentially is behavior we don't know the outcome that will occur from using a specific variable, because we haven't given that variable a value. So undefined behavior can present in several ways. It may exhibit producing different results every time it runs. So you might get -7 as a number, 7, 32, whatever, every time it runs. Or you could consistently produce the same incorrect result. That's -7, -7, -7. Your program behaves inconsistently. Sometimes it runs, sometimes it doesn't. It crashes immediately. It could work on certain compilers or certain systems, or it could just produce correct behavior and you don't even know that the variable hasn't been initialized. So this is like a Forrest Gump, if you've ever watched the movie, reference. Undefined behavior is like a box of chocolates. You never know what you're going to get. So it's undefined, it does what it wants. Yeah, so just be careful with this, and that's why it's good to initialize, at least zero initialize your variables, at least when you're learning. Take care to avoid all situations that result in undefined behavior, such as uninitialized variables. And then here's just a little note, just saying that sometimes some setup might work for your program, but really behind the scenes, it might just be undefined behavior. So just really keep your eyes peeled out for that. And then we have this quick section about implementation defined behavior, which is referring to behavior that's specific to a compiler or system that you're on. So just be aware of that. It's related to unspecified behavior, which is basically left up to implementation specific to your compiler. And it's generally good to avoid implementation defined or unspecified behavior whenever possible, because this might cause your program to run on one compiler and not run on the other. And yeah, that's about it. So I recommend you guys do this quiz. And thank you for watching. If you guys have any questions, put them in the comments below. Yeah, I'm having fun making these, so I'll continue and try to pick up the pace pretty soon. With that, I'm Deco. Peace.